Welcome to the project demonstration of IoT street light monitoring and fault alerting system by using Blynk application. So here we have the features. One is the day and night mode. The second feature is vehicle detection, and the third feature is if the street lights are getting fault, then that will be notified through the Blynk application using Wi-Fi ESP8266 module. So these three features executed by the Arduino Uno board. So to detect the day and night mode, we are making use of this LDR sensor. And next, to detect the vehicle presence, we are making use of this IR sensor. And next, fault detection will be identified by the LDRs which are attached to the individual street lights here. So we place this is the LDR connection for the street light 2, and this LDR connections for the street light 1. So these two are the street lights power supplies getting signal from this two transistor boards. So here we are using transistors to control the intensity of these two LEDs. So based on the LDR input, so if night mode detected, then only 50% of the brightness is provided to these two street lights with the help of the two transistors, and in the night time any vehicle presence, then the full brightness will be provided to these LDRs. So in this switching sequence, if any street lights getting fault, so then this particular LDR will inform to the microcontroller, means Arduino Uno, about the fault identification from the respective street lights. So that will be intimated to the Blynk application with alert notification. So if you didn't open the app also, you'll get the alert notification in your mobile phone. So here this is Blynk application, and this is the red icon will show the status of the device is offline now. Coming to the interfacing connections, so we have interfaced the IR sensor at the 8th pin of our Arduino Uno board, and these three LDRs, two LDRs for the street light fault identification. This is the one LDR to identify the day and night mode. So these three interface at the A0, A1, A2 pins, and the controlling pins for the street light intensity, these two transistors interfaced at the 9 and 10 pins. So this is the Wi-Fi module to go get data uploaded into the Blynk application, so which is interfaced at pin number 0 and 1, and this is the regulated power supply board. So here we are providing 230 volts AC input to the system. So this step down transformer will step down the 230 volts AC to 12 volts AC. So after this regulated power supply board, we will get the 5 volts DC output. So in this regulated power supply board, we have the three stages. So from this DB107 rectifier, so which will convert the AC to pulsating DC. To remove the pulses, smoothing capacitor was placed. So there is a 1000 microfarad capacitor. So we will get the 12 volts pure DC voltage, and this regulator will regulate the 12 volts DC to 5 volts DC constant output. So here this 12 volts is supply voltage for the LEDs. So from these transistor boards, so that's why we can see that. So these 12 volts are distributed to the transistor board. From there, based on the signal from the Arduino Uno, the transistor will allow the voltage in 50% and 100%. And after the regulator, the 5 volts given as input to this breadboard. So this is a breadboard to distribute the 5 volts power supply throughout the input and output modules in our whole project. So let us see demonstration. Before on the kit, we need to enable the hotspot in your phone. So for that, go to hotspot settings of your phone and change the hotspot name to project 5506 without any space, without any capital letter, and password should be 129, and select the AV band should be 2.4 gigahertz. So after on the data on the hotspots, and log into the Blynk application. So the device is offline now. So once you switch on the kit, the device will come to online and will keep on sending the data. Right. So the device is connected. Now it is online now. So let us place the some darkness to the LDR. If is there any vehicle presence, there is no operation on the LEDs. So just covering this LDR, then the 50% brightness was placed. And if any vehicle comes, then automatically brightness will be increases. So here, whether it is a 50% brightness or 100% brightness, if that particular LED getting off, so this is considered 2 is off, means there is no input to the LDR. So there we get the alert notification in a mobile phone, alerts fault at light 2. So then the respective department will taking care of the rectification process. Normal again. So this Blynk application can be accessed from anywhere in the world, as we are providing the data network. So as of now we have enabled the hotspot in this mobile phone, but you can log into the another mobile phone from the Blynk application, but you'll get the same alert notification. So that can be n number of devices can be accessed for the Blynk application. So if two are fault, and now it is normal condition.